All right, so lift is the name of the instrument, and the goal is to use the eddy current properties to find corrosion, detect corrosion, and eventually size the corrosion. And because we like challenge at Eddyfi, we like to do this without removing the insulation. And even if we have a metallic protective jacket on top of the pipe, we want to be able to do the inspection through a metallic jacket and through different layers of insulation. So we came with the lift system. The lift system, we'll be using pulse eddy current technology. I will give a quick overview of the instrument and the probes and the application, of course. So corrosion is a big topic, of course, in a lot of industries, so petrochemicals, nuclear, maritime, but most of the time can be difficult to look for this corrosion because you will need to have access, you will need maybe to remove insulation, insulated part. When it comes to storage, gas, sphere, for example, the legs made of pipe are covered with concrete. Breaking the concrete to assess the pipe and look after the condition of the pipe is also a challenge. So that's where a technology like PEC can help you reducing the load of the workload, I will say. So maybe no need for scaffolding, no need for insulation removal, no need for surface preparation. A quick system that will allow you to perform a quick screening of the installation of the component. And from there, focus only where you have to, where corrosion has been detected. So what is PEC? PEC is an electromagnetic technique, so pulse eddy current, as I said, only applicable on ferromagnetic materials, so carbon, steel, or cast iron. No PEC possible, not with this instrument, I will say, on stainless steel piping, for example. The goal is, as I said, to inspect through different type of non-conductive insulation. And if the insulation is covered with aluminum, stainless steel, or galvanized water jacket, up to 1.5 millimeter, you don't have to remove anything. You see an illustration on the picture at the bottom right of the slide. The goal is to look for corrosion, internal or external corrosion, of course. We are talking here about marine growth because we have some dedicated probe, let's say waterproof probe, so you can do inspection underwater also, PEC inspection underwater. And actually, we are more advanced regarding the codes with PEC compared to ECA because it's actually listed in the ASME code. We have an ISO standard, and also with the API RP, we have a mention of the PEC. Benefits of the technology: a non-intrusive inspection while the installation is in service. So you don't need to wait for an outage. You don't need to wait for a shutdown to do the inspection. You can do the inspection while the site is in operation. No need for coupling, no need for surface preparation. Usually, PEC is a bit, let's say, in competition with radiography, but radiography means radiation, means no parallel work when you do the radiography. So here you can have people, I don't know, welding or doing other type of inspection, UT, phase array, etc., and still being able to do in parallel the PEC inspection. Just one thing to take into account, an important thing to take into account, the measurement that will be given is a relative wall thickness measurement. So it will depend on what we call the footprint that I will cover in the next slide. So it can be applied on piping, vessels, elbows, tanks, ships. We have a set of probes, so we can go up to 100 millimeter of thickness for the inspected component. And with the lift off up to 300 millimeter, so 300 millimeter of insulation eventually. The technology is also tolerant to lift off variation plus minus 50%. So how it works, the video is not working here, but you have a probe creating a permanent magnetic field during a pulse, when we stop pulsing, what happens is that you have induced eddy current created in the material, and the time for the eddy current to vanish will be the time measured and will be, let's say, linked to the thickness that you will get. So the faster the induced eddy current will vanish, the thinner will be your component at the end. So that requires an initial calibration on a nominal thickness first before creating the sizing curve, I mean. So as I say, you have pulse on your coil creating magnetic field. When we stop, we are measuring the time for the eddy current to vanish. And you see at the bottom an illustration. I don't know if this works or not. It does. So you have different thicknesses here, from the thicker to the thinner, and then you have the slope of the curve linked with a particular thickness. Footprint is important. Footprint is important and depends mainly on the insulation thickness. And insulation thickness, in fact, is the lift-off, so the distance between the probe and the surface. That means that, oops, sorry. That means, merde. Oh, I've been too fast, okay. That means that the further the probe is, the bigger the footprint. The bigger the footprint, the bigger the volume, and the lower, let's say, the accuracy, the sizing accuracy. And what happened also, because we are giving an average measurement, you see here an illustration. So the same defect, which is large and shallow, compared to a smaller defect but deeper, will give exactly the same results in terms of average value. So this is also an illustration of what can affect the sizing accuracy of the system. So depending if you have a large defect bigger than the averaging area, bigger than the footprint, and then you will get a good sizing. We claim plus minus 10%. If you have one isolated pit, sorry, isolated defect smaller than the footprint, most of the time we will undersize this defect. Undersizing is dangerous when you do NDT. So in that case, you will need to have what we call the CWT, so compensated wall thickness, which is a tool, an advanced algorithm that has been developed internally by Eddyfi, just to correct the value. So here, an inspection of the part with with defects smaller than the footprint, I mean, with 70% measured, 73, 72% wall thickness remaining. In fact, once you apply the CWT, so the compensated wall thickness algorithm, we come back with a 30% remaining wall thickness. So deeper than what was measured initially. So this tool can be important also and very effective for better sizing. On the right, you have the same piece that was inspected also internally with UT. And comparing the results between UT, manual UT, and pulse eddy current, we came with something very close to reality. Some advanced tools have been developed also. System was launched in 2016, if I'm correct. So it's been a young system or a young technology, I will say, maybe 7 years, 8 years. Since the beginning, the company has always been developing new tools to help improve the sizing, improve the detection capabilities, etc. And what can happen also is that pulse eddy current technique is sensitive to material properties variation. So if I said at the beginning that we can only do PEC on carbon steel or cast iron material, but the carbon steel can have different permeability even on the same test piece. A weld can change the permeability locally. And this is something because you have still the insulation, you still have the weather jacket on top of your pipe, how to differentiate a variation of permeability from a defect. So we have now some new tools, like the perm tool, like the toe scan, that will help the analyst give a better diagnosis at the end. Some limitation still. Screening tool is not, you will get an average measurement, mainly based on the initial calibration. If the initial calibration is not done correctly, your measurement will be useless. So this is something we use to train the operators during the PEC training at the office, or just to make sure they know how to choose the right location to do the calibration. Limited to carbon steel cast iron, pulse eddy current technology doesn't allow you to know if the defect is internal or external. It just gives you the thickness measurement located, but doesn't tell you if it is near side or far side. Small pits, even through holes, are impossible to detect with PEC. It's better suited for large area of corrosion. And it's, as I said, sensitive to material properties. We know that we are undersizing the small flaw, but also this is the reason why we created the perm tool algorithm and the compensated wall thickness Tcndt tool algorithm. And last but not least, mass effect. If you have any structure, metallic structure, close to the probe, that can be a flange, that can be a nozzle, that can be a scaffolding around the pipe or around the component. This will also affect the results. And here, the CWT tool will be helpful in some cases, like when you are close to a flange, for example, and you have corrosion close to a flange. Quick overview of the system. So, pulse eddy current is a known technique for decades now. We came in 2016, as I said, with the instrument. From this, we developed some specific probe for galvanized steel jacket, for example, or for tank floor inspection. We came 2017, 2018 with a PEC array probe with a larger coverage to increase the productivity and the scanning speed. A new PEC HR, so high resolution. So this is the most sensitive probe that we have actually, but with some limitation. You cannot use it on all the configurations. And of course, some additional software to help for the analysis and diagnosis. If you look at the table, you will see that the ready and the lift is the same casing, the same weight, using the same batteries. So we tend to use the same box. If you look on the other side of the table, you have the sonic system. So this is Eddyfi trend to use the same boxes. The color change and help you recognize the instrument. Different probes, single element probe. We have it here, small, medium, and large probe. We also have a PEC array probe, 7 channels covering 180 millimeter in one single pass, faster than the single element with the same sensitivity. And different software. So the Lift Go software goes with the system and allows you to build your configuration, do your inspection, perform your analysis, and you can do the reporting also, all from the instrument. But if you need additional feature, additional analysis tool, for example, you also have what we call Lifter Pro, which is a dedicated desktop software. An additional and optional software available here is what we call Surface Pro 3D. So this allows you to build the 3D model of your component. It can be piping with elbows, it can be piping with nozzles, with flanges, can be a tank, can be whatever component you have. You can build your 3D component from there and just import the PEC data and overlay the data on your 3D model. So it's very easy then to show to your client where the defects are located in your component. Application, so corrosion under insulation, mostly piping. Here, a quick video, very quick video that shows, so on the right here, this is the old way to perform scanning. So you calculate your resolution, and from there you go to your test part and you have to draw a grid. So lines around the pipe and X location along the length of the pipe. and then you collect data, like you do with, for example, manual UT, and it takes forever. Sorry. I will not replay the video, sorry, but just to show you. So here we have introduced at Eddyfi, we are the first introducing encoded scan. So now you can connect an encoder to the probe, and you don't have to draw the full grid, only the lines along the pipe. And if you have the chance to use the PEC array probe, you don't need to draw anything. You take the probe, you go on your pipe, you adapt the probe to the geometry, to the diameter of the pipe. You have pens on the probe itself to draw the line live directly, and with maybe 2 or 3 passes, you cover the full circumference of the pipe. So basically, it will take maybe 2-3 minutes with this probe, 15 to 20 minutes with this one, and more than half an hour with this one. So comparing the new generation of PEC array probe to the old fashioned, let's say, we are dividing the time by maybe 10 or 15. Another well-known now application is the sphere legs. So the sphere legs is just a pipe covered with a layer of concrete supporting a storage sphere. And here, using the PEC array probe can be helpful. So either with scaffolding, and if you want to save money regarding scaffolding, you can use a rope access operator, also who can deploy the probe and can end with this type of detection. So here we are at the very bottom of the leg, I will say. We have a through hole at the end, and this was detected with PEC, and finally they just broke the concrete to access, and now this we know needs a repair before you continue using the sphere. I will pass this just quickly. Yeah, quickly. For this type of inspection initially, looking for scabs or blistering, where no other technique except radiography can be used. Obviously, because of the type of corrosion, UT cannot be deployed here. So looking for a solution to, let's say, compete or compare with the radiography, we came with this specific probe. So this probe here needs to be either in contact with the component or can accept some lift-off, but no weather jacket. And this is a test part that was given to our development team in Quebec from an asset owner. They had all the results from previous radiography inspection, and the engineers at Eddyfi, they developed the probe for that, and finally end with very close results to radiography. Just it takes less time to use the probe with no limitation regarding radiation, etc., and saving a lot of time for this type of inspection, for scab and blistering detection and sizing. Elbows is a geometry that was also difficult to address, so now you can do elbow inspection with PEC. Galvanized steel, galvanized is ferritic, galvanized is ferromagnetic, galvanized is bringing additional challenge to pulse eddy current use. And to address this challenge, what we have done is a specific probe, so the galvanized steel probe, by the way. Just this probe has a strong magnet embedded in the probe. So that means that the probe will stick to the weather jacket made of galvanized steel, will saturate the weather jacket, allowing the pulse to go through the jacket with less interference and less noise. At the bottom you have, so this is made with a standard probe, I would say, and this is made with the galvanized steel probe. We see that the signal to noise ratio is different. And of course, the sizing accuracy will be better with the galvanized steel probe compared to the traditional probe. Underwater probe I was talking about earlier. So up to 100 meters, of umbilical of cable, you can address inspection of platform structures. but also vessels, if you want to inspect ship hulls. And because PEC is tolerant to lift off, you don't need to, if you have marine growth, for example, on your piles, if you have marine growth on the ship hull, you don't need to clean everything. You can do the inspection, taking into account the lift off brought by this marine growth. A very specific application, it always has been a challenge to measure or detect corrosion at this specific location in a reservoir, in a tank. So provided you can access below the annular plate with a titanium probe, which is covering 400 millimeter, you can try to insert your probe underneath the annular plate and find corrosion, detect corrosion, and get an idea of the damage by sizing the remaining wall thickness. Finally, I think I'm close to the end of the presentation. So here again, a specific probe here that you can see, and we have it here also. 7 channels, 180 millimeter coverage in one single pass, encoded. Very well suited for deck inspection. We have developed that mainly at the beginning for the military navy, because they have ships that are 30, 25, 40 years old, and they want to expand their life, and they want to be able to detect corrosion and eventually repair as fast as they can. But initially, what they have to do is to remove the layer of whatever is on the deck. Can be paint, can be epoxy, can be ceramic tiles. So you have to remove that. You have to clean, prepare the surface, and then you do UT measurement. You start with the visual inspection, of course, as always with NET. So visual inspection initially, and then UT measurement. So long, let's say, time to do all this job. Here with this probe, you don't have to wait for the ship to come back to the harbor. So if you have the equipment on the ship itself, you can do the inspection while in operation, detect the area of corrosion, and then when you have your map back at the yard, they will be able to start directly the maintenance, saving a lot of time, and then also extending the lifetime of those vessels. And what is applicable on military ships is, of course, applicable also on the other ships, so cargoes or cruise ships eventually. So here another view of a test that we have done. I did it myself. It's a French, it's a French ship. I cannot say which one, but we made a test with this probe. Covered the full surface, highlighted the area of interest, and from there, they qualified the system, they bought the system, and now they are using it on a regular basis. Conclusion, so if you have some information to keep in mind about the lift instrument and about the pulse eddy current technology, the PEC technology, it's a vertical technique that will allow you to inspect carbon steel or cast iron through lift-off, so you don't have to be in contact with the component you're inspecting. This method is not a measurement method, but a screening method that will give you a relative remaining wall thickness, but that will also highlight the area where the damage are bigger than the other, and then you focus on the area of interest. And the most important part, I will say, is that you can do the inspection while the asset is in service. So you don't need to wait for a shutdown. You don't need to wait for a shutdown or an outage. You don't need to remove the insulation. You don't need to prepare the surface, and you don't need to use any coolant. This method, I think, and it has been proven, an effective method to save a lot of time, but just something to keep in mind, and maybe my colleague Edwin will talk about that later this afternoon. It's complementary of UT corrosion mapping, for example. UT corrosion mapping requires coupling, requires some equipment, a pump, water, etc. And you don't want to address 100 square meter of inspection with phased array UT, but it's really convenient tool because very accurate, let's say. So here you can inspect square meters with PEC, highlight area of interest, and then you can come back with the phase array technology to do the mapping. And I think I'm close to the end. Just talking about the training. So the training is so there's no actually training center, NDT training center, training or giving a training with PEC. It's in-house. We give the training at Eddyfi. It's divided in two parts. One, e-learning through the Eddyfi Academy platform that takes you about 10 hours, I will say. And from there, we have an hands-on training with a lot of samples. So it can be done in our offices in Paris. It can be done in our offices also in Swansea in UK, or we can come to customer location with the equipment, with the samples. And usually we accept up to 4 people per training session. At the end, you will get a training certificate. It's not an NDT certification like level 1, level 2. It just gives you an overview of how to use the system and what you can face in the field, in fact. Thank you. I hope it wasn't too long. Any question? Or you can keep the question later during demo.
Okay, hello everybody. My name is Rich McAllister. I'm from Scotland. I appreciate it's been quite a long presentation session already this morning, and lunch is not far away, so I will try and be as clear and slow speaking as possible, but also I appreciate the time frame and lunch is around the corner. So yeah, my role with Waygate Technologies is I'm our European channel partner leader for our ultrasound business, and I well, originally Waygate Technologies was formerly GE Inspection Technologies, and we rebranded around 4 years ago. We are a company that is owned by Baker Hughes, which is an oil and gas company. But our business is an energy technology company which provides solutions for the NDT market. We specialize in computed tomography, ultrasound, radiography, AGFA film. It's where we originally came from. Touching on that footprint that we have, that history, we have quite a large presence across the world. We have over 40 direct premises, customer solution centers, sales offices all across different parts of the world. Part of that footprint we can extend through our channel partners, which takes our coverage to over 80. Within our channel partner network, we have partners like Total Control, who have been with us for over 18 years and are helping us actively demonstrate, sell, promote, and support all our NDT customers across Romania. So a little bit about our heritage of Krautkrämer. You should all probably be well aware of Krautkrämer. It's a potent name within our ultrasound business that we wanted to retain when we rebranded from GE Inspection Technologies to Waygate Technologies. Originally, a gentleman called Joseph Krautkrämer developed the very first ultrasonic testing machine for the non-destructive testing market back in 1949. He and his brother Herbert Krautkrämer founded the company itself, in which we evolved the name Krautkrämer, which has been around for well over 70 years. So the purpose of this presentation is to launch to you and to tell you a bit about our latest flaw detector, our latest conventional flaw detector. It's called the USM 100. So I'd like to show you a little brief video on on the system, and then we can talk about some of the design features and what the device is all about. So the USM100, we are actively saying it's a smart, light, and versatile unit. We have developed this product to meet the challenges of an increasingly interconnected world, and we are quite proud to launch the only digital native portable conventional flaw detector on the market. Our focus when developing a new flaw detector was to create a sleek and rugged device. You know, we appreciate how harsh the environments are that then non-destructive testing works in. This device comes with great efficiency through remote access, data management and storage. It also operates with both touchscreen and with buttons. We are trying to raise the bar with conventional ultrasonic inspection with state-of-the-art hardware. We've essentially massively improved the performance with the connectivity, the touchscreen operation, how the ultrasonic performs on this device. Is a very, very powerful instrument. It's also very robust in the sense that it can be very scalable for other demanding tasks within ultrasonic techniques, specifically for conventional. One of the most important aspects of this device is that it's backwards compatible to old data. So we appreciate that our customers already have been with us for a long time. We cannot go as far back as to USKs, obviously, for analog processing, but this device has the capability to pull in data from USM Go and our USM36 range. We recognize how important our instruments feel, so we wanted to make sure that this remained lightweight. It weighs 1.2 kilograms. Technicians, I was formerly an NDT technician. I've used to work offshore for many years. I appreciate how difficult rope access work can be in confined space. So we wanted to make sure that we can still have a device that can be operated with one hand. It is an ambidextrous device, so we can essentially use it with either left or right-handed. It's IP67 rated. It's been put through intense, harsh environments, ruggedized for that purpose, and also it's waterproof, drop-proof, shock-proof. The operation of the system comes with either touchscreen. It can be operated with or without gloves in wet or non-wet environments. But we also recognize that there's other devices on the market, and customers sometimes have a preference to have a button to press and to feel a response when that button is pushed. So we've kept that as part of our operation of the unit. You can use buttons if you so wish. It comes also with a large 7-inch display, one of the biggest displays we've had on our portable flaw detector range, colour screen, and also the device comes with an internal battery and external hot swappable batteries. So in the NDT community, we all face similar problems in some capacity when it comes to inspection. Compliance and consistency, quality, probability of detection, and productivity are all at the forefront when it comes to inspection. So we now have developed apps on the USM 100 to help improve efficiency for our customers. And these apps are built using the free software that comes with the USM 100. So we have Mentor Create, which we use to capture the results of the data. You can analyze your data using USM 100 Mentor PC. Again, all included software, and you have access to our inspection work store, which is where you can download custom applications, apps. You, the customer, can design your own apps, your own unique workflows, and how you want to step-by-step calibrate the device for different skilled technicians. We have a brand new user interface. One of the main design aspects of this device was we want to make sure that we are reducing the amount of time technicians are spending interacting with the device to change parameters. So we've managed to design a concept where everything can be done essentially within a reach of your thumb, taking into consideration the situation that you will be in a ruggedized or harsh environment, lying on the ground in a confined space, working high, etc. We've designed the user interface of this instrument, which can essentially reduce the number of clicks considerably with our existing and competitive devices by 70%. We've also improved on the hardware. The bandwidth now for us is exceeded up to 30 megahertz. The power of this unit is far more superior to our performance of the USN60, which we can use or have been using for immersion applications. It comes with encoded access for X and Y corrosion mapping and scanning, weld inspection also. It comes with immersion gate if we want to use bubbler applications for testing machine tanks or immersion tanks, and improved our signal to noise ratio, and our near surface resolution is far superior than our previous models. On software itself, we have now designed a concept where we can scroll using our thumb. I can touch on that later on the device, on how we navigate around the instrument, but again, it's all touchscreen based. Also, the readouts on the system itself are all customizable. So sometimes it might be unclear to a new technician and or an experienced technician learning a new device. You can now just click on a parameter and it'll give you a brief explanation, description on what that is, what it does, and you can also change it live there and then. One of the new features that we have on this device, and it's quite an important feature for us, is the ability to do encoded B and C scan imaging. We had that similar kind of technology on our Mentor UT, which was our, I would say, entry-level phased array system for corrosion mapping, but we've now brought that technology into the conventional device. Again, we can touch on that later on. We have a nice immersion scan that we did with one of our application labs in Germany, and the resolution on this is superior. So now, with the USM 100, we want to be able to make sure that your data sets that you have on our existing portfolio can be used on our new portfolio. So the data sets, your setups, your calibrated probes, etc., all these data files can be transferred right across to the USM 100. This touches on some of the software that comes with the USM 100. The USM 100 comes in 3 different versions. We have a basic instrument, we have a pro instrument, which has the corrosion mapping features. We also have the digital, which is more for larger fleet customers who want to have full traceability of their sets across the portfolio. Mentor PC is what we use to analyze the data. So if you do your inspection, you capture your results. You can analyze that offline on Mentor PC. Mentor Create is what we use to design the workflows, the apps that you use on the instrument. Mentor PC Live is a tablet-based inspection, allow you to use third-party applications, remote access. And lastly, we have a new iOS app, which you can put on your mobile phone. Our plans are to develop also for Android, but currently at this moment in time, it's only iOS based. But this app allows you to use pictures, capture footage, imagery, and geolocation, specifically if we're using this in an environment like the rail industry, where location of a specific part in the track is quite critical on follow-up work. So this instrument is obviously designed around various different applications. Weld inspection is critical. We carry all the historic features, DAC, TCG, AWS. We've doubled our amplitude range up to 400%. We have backwall echo attenuation. We are obviously complying to all the various different ASME codes and AWS codes, where we have apps based around that. We also have similar apps for our nuclear industry also. Color legs for visually seeing where the beam skips are within the A-scan. We have now a far superior bandwidth, as I touched on before, going down to below 0.2 megahertz. So composite inspection is very important, and we appreciate how much work there is in the marketplace for composite work. So we now have an IF gate to allow us to use this device in an immersion tank, to allow water column or flexible wedge. We also have an improved higher slope TCG curve to allow us to work across the higher attenuative materials, rubber. We have an improved near surface resolution during that immersion tank process. Corrosion mapping is also another application that we are using the USM 100 for. Previously, in conventional ultrasonics, it has been primarily point thickness checking. We now have the capability on the USM 100 to do B and C scan corrosion mapping on the device. And again, touching on the railway application again, this is really just explaining how our user interface can be used to combine with our SPG3 track system. We have our geolocation app as well, which we can download and have on the customer's tablets or mobile phone. Square wave pulsar, is also a feature and available on the device. So what can we do better with our data? We have a subscription model which comes with the USM 100 for a period of time. If the customer wishes to extend that period, they can do so. Inspection Works essentially turns the data into a tool to make faster and better decisions, ultimately saving costs and enabling a more competitive product. Inspection Works is a software with Waygate Technologies, where we can use it to acquire, analyze, and act on the data that we are capturing. We can connect the entire inspection history of an asset or a product and enable the customer to add inspection insights to a digital twin of your product. The last part is touching on the digital side of the USM 100, where we are seeing it being used predominantly with large fleet customers. We can automatically sync the device to have software updates. If you log into your encrypted cloud-based system, you can automatically update USM 100 remotely. One of the benefits of this service is that the USM 100 can be calibrated remotely. So instead of having your device out of action for a number of weeks, this device can now be calibrated on site within an hour on your premises. This isn't an EN-ISO, this is just purely a manufacturer's calibration, but it's a capability that we are now offering with this device. InspectionWorks is a platform where we can centralize all the data, manage assets, share reports, and this is also in line with the visual business. We have the same service offering for our digital radiography with our Tcndt archiving for our digital imagery. And yeah, that's really just a kind of summary of this product and the offerings that we have with it. And it's now available from our channel partner Total Control for sale and for demonstrations, for trials. So if you have any technically related questions going forward, please reach out to Mugarel and Christian for more information on that product. So thank you very much. I'll be quick with this one. This is also a product launch that we are releasing in January next year. It's called RotoArray Compact. Another short video, and I'll explain the technology that's going to be inside it. So I'd like to introduce the technology, which is called Compact. Essentially what this is our first compact product that we've launched or are going to launch. What you see in front of you is a RotoArray. If you've not seen one before, it is essentially a fairly large wheel probe. It is like a small immersion tank on wheels, which we can use for a whole host of different applications. We've designed this around aviation industry for fuselage inspection. However, it can also be used for composite inspection on wind tower blades, towers themselves, tanks, vessels. It is quite a product that can be used for a whole host of different applications. What we've done is, the image you see in front of you is a very old phased array circuit board, and we've reduced the volume of that circuit board by 100 times. and we've managed to have this operate with a considerable less amount of power. Traditionally, this type of scanner has to be driven and powered by a phased array device, a system like our own Mentor UT or Eddyfi's Gecko to Olympus's OmniScan. These types of advanced phased array systems are used to drive the supporting ancillaries, accessories and scanners that complement that. We've now managed to revolutionize that technology with patented technology to reduce that the electronics now which can be put inside the wheel of this probe. So essentially that computer chip is the size of a USB pen. It's this big. It's very, very small. Before we had the old RotoArray, we would use for our scanning, we would have to have a multiplexer, which was on the back of our Mentor UT system. It was quite a cumbersome, heavy package, but we've now managed to reduce that package size considerably. So before, on the left, you see there is our Mentor UT system, and now on the right we are providing a tablet which you can buy from us. But if you don't wish to buy a tablet from us, you don't have to. You can buy a RotoArray Compact as a device on its own. It comes with software that you can put on your own laptop. You can put that software on your own tablet. What powers this RotoArray Compact is all in a USB cable. We've managed to remove the large coax cables. All the encoding, all the electronics, all the phased array communication is all done through a USB cable. So we've got a bit of a comparison here on some competitors as well as ourselves. Eddyfi are not here, okay, so it's all good. But the overall size and weight is one of the main drivers behind this. If we look at our own Mentor UT combined with our old RotoArray was well over 4 kilos. If we go into the competitive devices there, the weight does increase. Now we're launching our RotoArray Compact on its own at 1.2 kilograms. It's the same as a USM 100 device. Again, the weight of a tablet can fluctuate depending on what tablet you use, but the one that we are offering is under 1 kilogram. So this package together is around about 2 kilos. We've essentially halved the weight of the entire system, which also improves a significant cost reduction as well, because a phased array device is no longer required for this type of application. It's very, very light. Having the flexibility of the tablet is also a huge benefit to the customer. We see a lot of end users who have their own way of reporting. We understand that. They also have their own way of doing inspections using completely different competitors' devices. We fully appreciate that. What we did see was how they've captured and reported their results from that inspection, and it was on their own tablets. And that was in a whole host of different industries. So the same concept of planning, acquisition, storage, analysis is all done essentially on a tablet. And that is what's driven us to develop this RotoArray Compact to work with tablets and or PCs, depending on the environment. So the applications and industries that we are selling this to and using this in is quite vast. Aerospace is primarily the main focus for us. Aerospace structures, corrosion monitoring, aluminium blades, aircraft skins, wings and fuselages, EV batteries, helicopter blades, complex composite castings, we're looking for detection of or sizing of delamination and disbondments in the material, or quantifying porosity, corrosion, sizing, all these different types of things, discontinuities essentially, in a whole host of different materials. We can do this using the RotoArray Compact. So this here is our reference plate, which we use for demonstration purposes. Here we have our traditional A scan on the top left. It comes now with B scan, an amplitude C scan. Below that is our time of flight C scan, a D scan, and also an active view C scan. So what that allows us to do is, if we are have a particular area of interest, this same feature is also available on the USM 100. Let's say we scan a large plate, or we scan an area of composite material, and we want to really localize that specific area. We have a data box which will populate parameters based on encoder, X and Y location, distance from your datum point, the size of the defect, the highest amplitude within that area, the width, the depth, the height. All this sizing information is available in the active view window. So you'll have two active view windows on that device. So you could scan, a huge area, and you could just really want to zone in a tiny little area. You can do all that on the tablet. You can do all that on the USM 100. It's the same concept. We've tried to bring across the same way you operate the system, the device, so you're familiar with both. We've seen before where there's different systems, and technicians are very comfortable when they're familiar with how they operate daily. The improvements we've made on our old RotoArray was we've improved the handle. It comes with start-stop functionality with the buttons. Again, leakage, we fill the tire up with a propylene glycol, like an antifreeze. And we've also enhanced our UT performance as well with this new product. There's some information that we could touch on about the specs of the device. But to summarize, this is a very cost-effective solution where we see essentially our competitors have similar products but are considerably higher in cost and weight. All electronics are integrated directly in the probe, and you can connect this with a tablet or a PC, desktop or whatever, if it's lab-based, university or educational purposes, right through to in-field inspection. It can all be connected using a USB. Again, this is just touching on the ease of use. The way you calibrate and set up the system is similar to how Miguel described the USM 100. There is workflows, there are step-by-step instructions on what to do. It's very, very user-friendly. Again, with having the connectivity of a tablet, you can connect to your own network on your own device. You can connect to our inspection works also, if that's something that is of interest to you. Where we are taking this technology, we are also developing other products that we're going to launch next year. But this gives you an idea of the direction our business is taking, our methodology, and what we can do and evolve as part of the Krautkrämer brand. Again, Total Control, a fantastic loyal channel partner that's been with us for a number of years. This product will be available to them hopefully within the next 6 or 7 weeks, and Total Control will be rolling out trials across Romania. So please, if you have any questions or have any interest in trialing this equipment, please reach out to Christian, Miguel, and they will support you with any further information. Okay, thank you very much. Cheers.